Parts per million training objectives. Number 1, you will be able to define parts per million. Number 2, you will be able to describe and explain what titrimetry is. And number 3, you'll have a good understanding of parts per million and you'll be able to apply your new knowledge to your job at Bushnell Industries. Parts per million defined. Parts per million is a way of measuring how much of a substance is in a dilute or concentrated mixture. Just like percent means out of 100, parts per million means out of 1 million. Parts per million is abbreviated with PPM. Parts per million is the measurement used when there are very small concentrations of a substance in a solution. Parts per million is smaller than parts per thousand. Parts per million scenario example. Bob says, "This mixture is 850 parts per million iodine." Translation: if we were to take 1 million atoms out of the mixture, then we would find that 850 out of the 1 million elements is iodine. Parts per million gumball example. These gumballs represent different elements that can be in a mixture. Pretend that each color represents a different element. Now, pretend that in this mixture there are millions of gumballs, and we want to find the parts per million of the orange gumball. After separating out all of the orange gumballs, we count 9,995 out of 1 million gumballs are orange. Therefore, the parts per million of the orange gumballs is 9,995 parts per million. Let's practice longer. Let's say out of 1 million gumballs, 168 are green gumballs. That means 168 parts per million are green gumballs. Let's say we have 1,255 red gumballs out of 1 million. That means 1,255 parts per million are red. And we count the blue gumballs and we count 7,893. That means 7,893 parts per million are blue. Last, we count the yellow gumballs. We count 5,421, which means 5,421 parts per million are yellow. Parts per million testing in the lab. Testing for parts per million in the lab. At Bushnell Industries, we use a chemistry test known as titrimetry. We use titrimetry to find out the concentration of a known substance in a liquid solution. Titrating a liquid. Titrimetry is a quantitative chemical analysis that is used in the lab to find the unknown concentration of a known substance. Usually, if test results reveal large concentrations, results are explained using percent. Medium concentrations, results are explained using parts per thousand. And small concentrations, results are explained using parts per million. Titrating a liquid, the titrant. The titrant is a pre-prepared solution that chemically reacts with the indicator in the test solution. Usually, the chemical reaction is a change in color or clarity within the test solution. The titrant is added to the test solution by using an instrument called a pipette. The exact milliliters of titrant used to cause a chemical reaction to occur is recorded. This recorded measurement is then mathematically converted with a pre-prepared mathematical equation to parts per million. A common titrant used at Bushnell Industries is a sodium thiosulfate prepared solution. Titrating a liquid, the indicator. An indicator is used in titration tests. The indicator is added to the pre-measured test solution before the titrant. The indicator used is specific to each titrant test. The indicator reacts with the solution in titrant, causing a visual chemical reaction. A common indicator used at Bushnell Industries is called phenolphthalein indicator. This indicator is used to titrate acid and alkaline products. When it reacts with hydroxide, it turns pink. Note that not all titration tests require an indicator to be added. Titrating a liquid, the test solution. A titration test is also considered a volumetric analysis. In other words, the test results are fully dependent on the volume of the solution being tested. The mathematical calculation used to determine a mixture's unknown concentration is specific to the volume of solution that is to be tested. This means, if a titration test requires 20 milliliters of the solution to be tested, then 20 milliliters of the solution is measured and placed into a beaker to be titrated. Below is an example of a 20 milliliter solution sample of iodine. This is required for a Bushnell Industries iodine titration test. Lab test iodine titration. The test solution is an iodine teat dip, and the titrant is sodium thiosulfate solution. The QC carefully administers the titrant with a pipette into the test solution. Once the equivalence point is reached and the chemical reaction occurs, the amount of titrant used to cause that chemical reaction is recorded. In this example, we use 16.2 milliliters of titrant. That means that this solution is 10,200 parts per million iodine. If the iodine solution is 10,200 parts per million of iodine, out of 1 million atoms in the mixture, how many atoms are iodine? (10,200) out of 1 million are iodine. Good job! Bushnell Industries and parts per million. At Bushnell Industries, we emphasize to our employees the importance of understanding basic chemistry. Whether you are in the lab, working in the field, or part of production, you will be using parts per million. Being a competent and knowledgeable employee is important to the overall success of Bushnell Industries.